Alright, so in this particular example here, we are trying to do the batch calculation so that we end up getting a glass, right, of this composition. This, and then this. So this all here is a glass, right? So our aim is to get the raw materials and do the batch calculation so that when you put those masses in the furnace, you get the glass being 100%. Sorry, you get the glass being 100 grams, right? And then we have the specific amount of component, right? But then there are some things we should notice before we do anything like this. So when we see something of this sort here, what we're trying to see is the glass made of 20% sodium, right? And we have 5% Al5, right? It's 5% Al2O3, and then we have 75% SiO2, right? So that's all what we have here is saying, right? But then there's something else that we should notice. The other thing is that some of the components of the glass exist on their own, like you can get them raw. So like so let's say something like SiO2. When we have pure sand, you get the SiO2 direct, right? Alumina, you can get it direct, right? Generally, this one here mostly comes in this form, right? Yes. So that's another thing we should notice. Another thing too that we should take note of is the gravimetric factor. That's what we call it, right? So the gravimetric, right? Gravimetric factor, which is the same as GF. Now I just want to write this out. Gravimetric factor. What this one does is that it's basically comparing masses or weight of a particular raw material and it's a component that you can get from it, right? So let's see this GF here. Let me write it out. The GF here, the gravimetric factor, is the same as molecular mass. There are two ways of writing it. Molecular mass of raw material. Two ways of writing it. It actually compares molecular mass and what do you call it, mass, right? So molecular mass of raw material all over our molecular mass of a component of the raw material. That's what it means, right? Which is the same as mass for a particular thing, mass of raw material. So two equations all represented by the GF gravimetric factor, right? All represented by that. Let's see, mass of component, right? So that's what we have. So let's say using this one for instance, Na2CO3, and then this, we know that this Na2O, you can get it from this, right? When you heat this one at high temperatures, right? So meaning that if you are trying to get a gravimetric factor, and you can use the molecular weight of this one comes here as a raw material, and then this molecular mass here comes here as a component of this Na2CO3, right? So then if you have their masses too, it's just the same thing, right? So that's what those things mean. Let's see. So it's good that you get that one in mind. When you get that in mind, you'll be fine everywhere. So the same thing, if you have the mass of this mass of factor, mass of the raw material, and then the mass of the component of that raw material gives you the gravimetric factor. Okay, so these are the things that you should get in mind. And when you have this in mind, you see this GF is the same as equal to this, right? So when you have that in mind, you'll be able to do whatever it is that you want to do. So the next question is, for us to be able to find the amount of each and every component that we need, it's very clear that you can get SiO2. Let's see. Let's try and do the percentage molecular mass, right? So that's how we go about it. We know the molecular mass of Al2O3. Let's see. Molecular mass of Al2O3, that's 2 to bracket 27, right, plus 3 to bracket 16, right? Molecular mass of SiO2, does that give us 28 plus 2 into bracket 16, right? All these have a unit of gram per mole, right? Gram per mole. And then molecular mass of, what do we have? Na2O, right? So let's see. Na2O, that's a 2 times 23 plus 16, right? Gram mole. Let's see what these values give us. So this ends up giving us let's see, times 27, right, plus 3 times 16, that gives us 102 grams more, right? And this gives us 28 plus 2 times 16, that gives us 60 grams per mole, right? And then this gives us 72 gram per mole, right? Okay, so now that we have their percentage, this is actually their molecular mass, but the one thing we have to do is to find the percentage molecular mass, right, which is this percent that they have in the actual glass here multiplied by their molecular mass, right? So you can write it this way: percentage molecular mass of the Al2O3 is the same as what we're having. The percent is in the glass. The percent of Al2O3 is 5%, right? So that's 5% of its molecular mass, which is what, 102. So 5%, and that gives us 5.1 gram per mole, right? And then the percentage molecular mass of SiO2, right? SiO2 is about 75%. Let's see, yeah, 75% of the molecular mass, which is 60. What do we get? 75% times 60, that gives us 45 gram per mole, right? Right, and now percentage molecular mass of Na2O, right? That is let's see, 20% of it. So 20% Na2O, 72. That gives us 14.4 grams per mole. 20% of 72, right? Let's see. $72, right? Let's see. %, so Na2 20%. Yes, of 62. Right. Let's see if you are doing something wrong. This is 2 times 23 plus 16. That's 62. So there's 62 here. 62. Yeah. 2 times 23 plus 16. 62. Yes, there's 62. Right. So now that we have this 20%, 62, that's 12.4. It's 12. So now we have this, meaning that the molecular mass of the glass will be the sum of all these, right? So let's see that what that gives us: 5.1, 45, and then 12.4. That gives us 62.5, right? 62.5 grams per mole, right? And then here's where we do fraction, right? The fraction gives us actually a portion of what we need. So let's say if we want the let's see. Then again, now here let's go back and let's see. We said that clearly we need a particular amount of this Al2O3 and then SiO2 and then this one here, right? So let's see. We can go step by step and then find the mass of this Al2O3 that we need, find the mass of SiO2 that we need, find the mass of what we need here, and use it to find this one, right? So let's see. Let's find the mass of the Al2O3 that we need. So here's where we need the fraction. So the mass of AlO2, Al2O3 needed, required, right? That will be the mass of Al2O3, molecular mass rather, percentage molecular mass of the Al2O3 all over molecular mass of glass, right? Times mass of glass, right? Let's see what that's given us. Al2O3 is 40, that's 5.1, and that of glass is 62.5. And the mass of the glass was, we want it to be 100 grams, right? Let me change this, it's too much. So what do we get? 5.1 on 62.5 times 100, right? And that's giving us, you actually need 8.160 grams of Al2O3. This is what we need, right? We'll get to what we actually need, but we have to find the mass of this one in the actual glass if we end up finding the product, right? So, and then the mass of the SiO2 in glass. So let's see in the glass. Let's see. Let's just make this in glass. In the glass. In glass, yes. Right? That will be the percentage molecular mass of the SiO2. We have that to be 45, right? So that's 45 over that of glass, 62.5, times mass of glass. What does that give us? That gives us 72 grams of the SiO2. That will be in the glass that we make after we do the melting and everything, right? And the mass of Na2O in glass, in the glass, that will be, let's see, its percentage, that's 12.4 all on molecular mass of glass, 62.5 times the mass of the glass, right? Because this one here is grams per mole, right? A minute. This one here is grams per mole. It's not clear. Let's see. The top one is in grams per mole, right? This one is in grams per mole, this one in grams per mole. That gives us a fraction, right? That's why we multiply it by this 100 grams here, we end up getting everything in grams, right? So this part is what we call this one is actually the mole fraction, but we're just doing it straightforward so we can get the mass, right? So that's what we are doing here. So with this we get, let's see, 12.4, right? And that gives us 19.84 grams. So this is the amount. If we end up getting a glass of 100 grams, right, this is the mass of alumina that will be in it, right? The mass of silicon that will be in it, and the mass of Na2 that will be in the glass. That's if we have the glass to be 100 grams, right? But then the question is saying that we are not using this, we don't have these three components directly, right? But what do we have? We have this right here, which is actually feldspar. There's a particular name for it, but like it's a type of feldspar, right? So let's see. Don't worry about the name, we don't need it, but you just have to know the composition. That's why even that's the only thing given, right? So this right here is a rock material feldspar. This sand, pure SiO2. That's why we just say SiO2. And then this one here, this is the raw material, which is a source for this Na2, right? So now we know the mass of Al2O3, SiO2, and then Na2 that will be in the glass if we end up doing everything, right? So we have to check the amount of this, right? We need Al2O3, and the Al2O3 is only coming from this feldspar. So we have to check the mass of the feldspar that we need. That will give us this mass of what do you call Al2O3 or alumina in the glass to give us this. So that's where the gravimetric factor comes in, right? So let's see. So looking at this one, as we were doing earlier, it's important to point out the raw material and the component, right? And we are seeing that we are getting Al2 from what? This feldspar. So this right here is our raw material. Okay, those ones are very important. Be able to identify your raw material and the component. We know this right here is the raw material, and then the component we're getting from it is Al2O3, right? So when we compare it, we can see that if you are doing gravimetric factor something, molecular mass of raw material, which is the molecular mass of all of this, right, and then all over the molecular mass of the component, right, will give us the GF, or the mass of the raw material all over the mass of the component that we are looking for, right, of a component. Because there might be times where it's not the component they are looking for, you're actually looking for the raw material, the mass of it. But we'll go step by step to see what's actually happening. So let's see. So now we actually know the mass of each component that will exist in a glass if we end up getting a glass of 100 grams, right? But then we actually want to know the amount of the raw materials we must put in the furnace, right? So now our aim is to find the mass of the raw material, which is the feldspar, right? So if you want to do something of that sort, looking at this here again, when you try looking at this, oh, I'm coming. These equations here, this is the key to whatever it is that we are doing here. This equation, right? So what's our aim? Our aim is to find the mass of what? This feldspar here, which is this, right? And there's it's a raw material. So you have to find the mass of a raw material. Is the same as bringing the what do you call it? The molecular mass of a component, and then multiply it by the J factor to give us the mass, the molecular mass of the raw material. But we actually need the mass of it. It's the same as bringing the mass of the raw material. Sorry, the mass of the component and multiplying it by the J factor, right? So now let's write it out. Right now our aim is to find what? The mass of the feldspar, right? The mass of the feldspar. So let's see. Small bit. Mass of the feldspar. So now let's write the equation out and then we find what we need, right? So we actually need mass of feldspar, right? And from what we're checking at that side, we know it's the same as having the gravimetric factor and multiplying it by what? The mass of a component that we are looking for, right? So at the moment, our aim is to find Al2O3. This is our aim right now. So let's see. What are we trying to do? We're trying to find the mass of the feldspar that we need, right? Which is that big formula that we saw up there, right? And then from this, the gravimetric equation that we were looking at, this right here, right? As we've discussed, we now have to get the mass of that, the feldspar, which is the raw material, is the same as the GF, right, times the mass of the component, right? In this case, let's say our aim is to find Al2O3, right? We are doing this first because definitely we need a feldspar, right? Because we get the Al2O3 from the feldspar, which is this big formula that we are seeing here. What's it? This right here, right? We're actually trying to find the mass of this one we need first because we definitely need Al2O3, and then the Al2O3 only comes from this feldspar. Are we okay? So that's why we are finding the mass of that one first, right? Talk about what's happening, and then mass of the Al2O3 in glass. Let me write it that way. In the finished product, in the finished glass that we have, right? So now to find this one, the GF, we know that the GF relates not only mass but molecular mass, right? So our aim is to now find the molecular mass of the feldspar, whichever way that you do it, just make sure you get the concept. When you get the concept, you can decide to find even the GF first. You'll be fine. It's still the same thing, right? Right, and then this is mass of Al2O3 in glass, right? That's what we are doing here. So let's see. Molecular mass of the feldspar, molecular mass of the feldspar is about 5 to 4. You can add them. It's like find the molecular mass. If you're trying to find the molecular mass of this feldspar here, right, is add the molecular mass of this, molecular mass of this, and then when it comes to this one, 6. I think this should be clear, right? When it comes to this one, 6 times the molecular mass of the SiO2, right? And then when you add all these, this gives you the molecular mass of this, which is about 524. You can check that later. I'm just trying to get the concept across. So that's about 524. Let's see. That's 524, right? A molecular mass of Al2O3. That's 2 times. That's 102, right? 102 times the mass of the Al2O3 in glass, which we had that one to be 8.16, right? Yes, 8.16 grams. So we have a feldspar mass. We need, not that we have, 54 or 102 times 8.16, right? So we need a feldspar amount of 41.92 grams, right? But then again, this feldspar that we are bringing in is not only coming with the alumina, right? It's coming in with SiO2, right? And then Na2O. It's coming in with this and that, right? So it's very important that, right, and this and that. And then it will be easier to go by this. You know that which one of them is direct, right? The SiO2 is direct. We actually need SiO2 directly, so you can just find the mass of the SiO2 that it brings, and then you know the amount of sand that you add. So let's do it. Let's see the amount of SiO2 that will come with the feldspar. So let's see. So then again, what are we trying to find? I'm trying to find the mass. Let's do this for the mass of SiO2 in what? Feldspar, right? So meaning that we're trying to find the what? The mass of a component, right? And then we know if you're trying to find the mass of component, let me go over this once more so that whenever we are going there, we know what whenever I'm writing, we know what we are doing, right? The gravimetric something. So to find the mass of a component, what do? I just what do you call it? I bring the mass of the component up and I divide the raw material. I bring this one here and I bring the gravimetric factor down, right? So to be, let's see. So the mass of the SiO2 will be what? Let's see. The mass of feldspar all over the gravimetric factor, right? So that's how to be. So we know the mass of the feldspar to be what? That's what we hear. You have 41.92, right? That's 41.92 all over the gravimetric factor. Let me just do division, right? There's division, and then the gravimetric factor is the molecular mass of the what do you call the feldspar. That's raw material over component, and the raw material is 524, right? The component, which is SiO2, that's 28 plus times 16, that's 60, right? There's grams here, so let's see what we get. 41.9 divided by this, that's 524.60. So that's 4.7. Okay. There's been a slight mistake. You see, when we're looking at the feldspar, we said the amount of SiO2 there is actually like 6 times, right? 6 times. So if you are trying to find a component of it, the molecular masses are important, right? Because here the molecular mass of that one is just 524. Of the feldspar here is 524. This one here is 524, but this one here for the SiO2 in it is 6 times the general molecular mass of SiO2, right? Yes, take note of that one. Get 524 on 60 times 6, right? That gives us 28.786 grams, right? So this is what we're having. The amount of the mass of the SiO2 that will come with the feldspar that we are using as the raw material, right? And then now we need mass of Na2. We are checking the mass of the NO2O in the feldspar that will add to the system before we melt everything, right? The same thing, mass of feldspar, right? All over what? Gravimetric factor. And then the gravimetric factors, it always changes depending on the raw material component, right? So here, mass of feldspar is 41.9 grams divided by molecular mass of, we are trying to find this one now, that's why I brought this division here, right? Molecular mass of the feldspar is 524, right? And then molecular mass of the Na2O, right? That's times 23 plus 60, that's 62, right? So let's see what we are getting. That's 41.9 524 on 62, right? So that's the amount of Na2O that will come with the feldspar that we add into the system will be 4.958 grams, right? We are still not done, right? And now we explain that we know that the raw materials, let's go over this one more time. Then again, it's very important you have the raw materials in your head, like you know those ones. The raw materials are 1, 2, 3, the feldspar here, SiO2, pure sand, and then we have this, right? We know the mass of this raw material that we must put in the system, right? And then we know the contribution that this amount here will give. We know the contribution that this particular feldspar here will give, respect the amount of the Na2 that to give, the amount of the SiO2 that it will give, right? But then when you check it, you actually see that the amount of SiO2 that the feldspar is given is not up to the actual amount of the SiO2 that we actually need to form the glass. So let's check this, right? So let's see. Okay, it's somewhere down here. The mass of SiO2 in glass is 72 grams, right? So if you check it and you check it with the amount of SiO2 that the feldspar is given, you see this is just 28, so meaning we don't have all the SiO2 that we need, so you have to add some sand or pure silica, right? So that's where we see that the mass of sand needed, or you can write SiO2 needed, that will be let me just write the representations. The mass of SiO2 in glass, right? The mass of SiO2 in glass minus mass of SiO2 in the feldspar, right? That will give you the mass of sand that you must add, right? So that's about, let's see, 72 grams minus 20.78, 28.786 grams, right? Yes. So that'll give us the mass of sand, which is a raw material that we must add, right? So that's 72 minus 28.78, right? 786. That's about 43.214 grams, right? So this is the amount of raw sand, which is a raw material that we must add, right? So now we know the amount of feldspar that we must add, the amount of sand that we must add. The next thing is to find the amount of what? What do you think? Because the question is saying that we are not adding Na2O, we are adding what? Na2CO3, right? So here is where we have to find the mass of the Na2CO3 that we must add, right? But then we already have a particular contribution of the Na2O from the feldspar, right? So to see the amount of Na2O that we need more, the extra that we need, we just subtract, do some subtraction. So let's see. So this is what we are, mass of Na2O additional. Let's write it that way. Mass of additional Na2O needed, right? That will be the mass of Na2O in glass minus mass of what? Na2O in what? Feldspar, right? So what's that giving us? The amount in the glass that we need, what is it? Glass. 19.84 grams, right? So let's see. That's 19.84 grams minus the contribution from the feldspar. That's 4.958 grams. So this calculation gives us the extra Na2O that we need, right? 4.958, right? 958. Yes. So that's 882 grams, right? This is the extra that we need. Additional, this one needed, right? And then why are we getting this? Why are we going to get this additional? We know this one. We need this amount. Let's write this out. We need this particular amount in a glass, right? But we need, and then the first part is giving us a portion. So this is what is left that we must add. So to get this, we're actually going to get it from the Na2CO3, right? Na2CO3. This is the additional. This is where we get our additional, what's it called, Na2O from, right? Our additional Na2O will come from this, which is a raw material, right? So let's see. The final calculation we are done. So we actually need what? A particular mass of this one, right? So then again, a mass of a raw material, or let's say mass of Na2O needed, Na2CO3 needed. That's why you must get those gravimetric equations. When you have them in mind, you'll be able to manipulate it whichever way you want, right? So we need that of a raw material. It's the same as the gravimetric factor, right? Times mass of what? The component that we are looking for is Na2O, right? Mass of Na2O, not just from anywhere, the additional Na2O needed, right? So let me write this out so we understand it. Mass of additional Na2O needed, Na2O needed, right? That's what we need. So that's how we are going to do it. Then again, the gravimetric factor depends on the component raw material they are comparing, right? And then for the Na2CO3, the molecular mass, that's 2 times 23 plus 12 plus 3, 16. That's 106. And then there's the raw material, right? Molecular mass of the Na2O, which is this here, that's 2 times 20 plus 16. That's 62, right? And then the additional Na2O needed, right? Which is 14.882 grams, right? So let's see, 106 on 62 times 14.882, right? So the amount of this raw material that we need will be 25.443 grams. Yes, so that's it. So then again, when you look at this very well, you get to see the raw materials that we need, right? So the raw materials that we need is actually this particular one here. We need this particular amount of it, 25.443 grams of it. The next raw material, let's see, where is it? Should be somewhere here. Sand. Alright, so the mass of the sand that we need is actually this, right? There's the second raw material. Let me just write this. There's 2, there's 3, and then 1. The mass of the feldspar, what is it? Which is what we found earlier. Yes, mass of feldspar, this right here. Yes, so these are the raw materials, these are their masses, these are the calculations, the equations, and the understanding. So yeah, that's it. All right.